Hello students, today we are starting a new unit on congruent triangles. Today we are going to just learn about the parts of congruent triangles. Congruent figures, these are figures that have the same size and the same shape. So it kind of looks like an exact duplicate, but the congruent figures are in different positions. Okay. Since this whole unit is over triangles, to be more specific, congruent triangles, if they are figures that have the same shape and the same size, then they are triangles in which the corresponding angles and sides are congruent. Remember what corresponding means. Corresponding means that they are in the same position, or the same relative position. So we'll look and see what that looks like. In example 1, it says if triangle ABC is congruent to triangle DEF. This is called a congruent statement right here. Really important. And this tells you everything you need to know about how the triangles are congruent. So this is called a congruence statement. So this tells you basically which angles and which sides go together. The order of the letters is the key to all of this. So basically, vertex A, since it's in the first position, matches with vertex D, which is also in the first position. So those two vertices correspond. Vertex B goes with vertex E because those are both in the second position. Vertex C corresponds to vertex F because those are both in the third position. So we're going to use that to kind of help us. Since A and D are in the same position, that means those two angles correspond and are congruent. So we can say angle A is congruent to angle D. Now remember, this congruent symbol in the middle means just what we said about the triangles being congruent. Corresponding angles and sides are congruent. So let's keep going. B and E go together, so that means those two angles correspond and they are also congruent. And vertex C and F are corresponding, so those two angles are also corresponding and congruent. This also applies to the vertices, to the sides. So notice how A and B are the first two letters, D and E are the first two letters. So that means those two segments or sides are also going to be congruent. So AB is congruent to DE. Remember, when you write a segment, you have to put the line on top, okay? To show that they're congruent on our picture, we use the tick marks. Segment letters B, C, and EF are in the same position in our congruent statement, which means that those two segments are also going to be congruent. They correspond, BC and EF. Now remember, when you write these segments, DE and EF, you could also write them as ED and FE. So the order there doesn't matter. The order that's most important, though, is in this congruent statement. That's the order that matters. Okay? And then the last two segments, AC corresponds to DF. So because the triangles are congruent, those segments are also congruent. So if you notice, there are a total of 6 pairs of both angles and sides that are congruent in congruent triangles. In this example, we're given another congruent statement. Triangle XYZ is congruent to triangle WMN. X goes with W, Y goes with M, and Z goes with N. So this is one way I could write this congruent statement. However, I could rearrange the letters on both triangle names so that they still match up, but so that the congruent statement looks different. but still holds the same corresponding vertices, angles, and sides. So we're going to look at each of these and see if they would work. So for the first one, it says that y goes with w. If I look up at the top though, this says y goes with m. So this one will not work. This one will not work. All right, B. The first letters are Z and N. If I look at my congruent statement up at the top, Z and N are both in the third position, so that's good. Let's keep going. X and W, those are both in the first position at the top congruent statement, so that's good. And then Y with M, Y and M are both the middle letters in the top congruent statement, so this is an equivalent way to write the congruent statement at the top. So B is good. C has Y with N. However, in the top congruent statement, Y goes with M, so this one will not work for us. And the last one, Z goes with N. In the top, Z also goes with N. Y goes with M. In the top, Y goes with M. And X goes with W. In the top, X goes with W. So this one also will work. So in these examples, we're going to use the congruent statement to name all the pairs of congruent angles and the pairs of congruent sides. So we've got two congruent statements. So let's look at the first one. E goes with K, H goes with F, and G goes with G. So we're going to use that to help us. Let's go with E and K. That means these two vertices correspond, which means their angles are congruent. So angle E goes with angle K. The next two letters are H and F. So vertex H and F correspond, therefore their angles are congruent. Angle H is congruent to angle F. And then it says G goes with G. So notice how both triangles have G. They share vertex G. So that means the angle on the left triangle at G and the angle on the right triangle at G are congruent. Now I can't say angle G is congruent to angle G because that's not specific enough. There are several angle G's. So this is where we would have to use three letters. So the angle G on the left, we could call angle EGH or HGE. Either one is fine. I'm just going to say EGH. The angle G on the right, we can call either angle FGK or KGF. Either one is fine. So I don't have to worry about corresponding vertices when I'm writing the angles that are congruent. Only when I'm talking about the triangle congruent statement. Now let's look at the sides. So the way that I do the sides is I'm going to be looking at my picture now because I know which vertices go together based off my congruent statement. So in my picture, I see segment EH connects my 1 and 2 arc angles. On the other triangle, segment FK also connects my 1 and 2 arc angles. So that means segment EH is congruent to segment FK. Remember, on these segments, the order of the letters doesn't matter as long as you have the two endpoints together. All right, let's keep going. The segment between the segment HG, which connects my 2 and 3 angle or 3 arc angles, is going to correspond to segment GF, which also connects my 2 and 3 arc angles. So segment HG is 1, and it is congruent to segment GF, which by default leaves my last two segments congruent, EG and JK. Now, whenever we have congruent triangles, in the last example, they were just next to each other. In this example, they were just right next to each other. One was kind of slid over. That's called a translation, if you recall. In this one, if I look at how my triangles correspond, I didn't just slide the triangle on the left over to the triangle on the right. I also did not reflect it. I actually rotated it. Okay? So this is an example of a rotation. So you don't necessarily need to know this, but if you can see how the triangles are congruent, then that kind of helps. So we have translations, rotations, and reflections. That might help you a little bit. All right, let's look at the second example. A goes with C, B goes with D, C goes with A. All right, so angle A, or vertex A on triangle ABC goes with vertex C on triangle CDA. Now, those two angles, I would have to use 3 letters because for angle A, there's several, and for angle C, there are several. So for the angle A that I put the 1 arc through, we could call it angle BAC or CAB. Either one is fine. For the angle C that I put the 1 arc through, we could call it angle ACD or DCA. Either one is fine. Okay. The next letters that correspond are B and D in my congruent statement. That's this angle and this angle. So those are congruent because those are the only angles at those vertices. I can just call them angle B and angle D. The last 2 angles, C on the top triangle and A on the bottom triangle, go together, but once again I've got to use the 3 letters. So angle C on the top triangle I could call angle BCA or ACB. And angle A on the bottom triangle I could call angle CAD or DAC. Either one is fine. So those are my 3 pairs of congruent angles. Now let's look at the sides. And I told you how I like to do the sides. Now I like to look at the picture. So AB, for example, connects the 1 and 2 arc angles. On the other triangle, segment CD connects the 1 and 2 arc angles. So those 2 segments are congruent, AB and CD. Remember, I could also call that BA and DC. Doesn't matter. Segment BC connects the 2 and 3 arc angles. Segment AD also connects the 2 and 3 arc angles. So those segments are also congruent, BC and AD. Now, if you notice, both triangles share segment AC. So that means they've got to be congruent because it's the same segment. So you would write it like this. AC is congruent to AC. Now, whenever you say that something is congruent to itself, like this one right here, this is because of something called the reflexive property. And we'll talk more about this later. It doesn't have anything to do with reflection, but if you think about reflexive, well, we'll talk about it a little bit later. Just know that that's how you can say something's congruent to itself. All right, if you look at these triangles, they are not translations. I did not slide the top triangle straight down. I also did not flip it. If I flipped it, for example, over AC, then this angle and this angle would be congruent, which they're not. So what I actually did was also, once again, rotate these guys. So this is another rotation. This time we're starting with our picture with all of our markings, and we are trying to make our congruent statement. So one of the triangles has been named in the first part of our congruent statement, ABC. We just need to use the letters of the second triangle in the correct order. A has the right angle. D also has the right angle, so A must correspond with D because those angles are the same size. B's got the 2 arcs. E also has the 2 arcs, so B must correspond with E. And C has the 1 arc, so does F, so C must correspond with F. Now let's try to figure out what type of transformation underwent between the first triangle and the second. We did not slide it over. It does look like we reflected over an imaginary line. So this is definitely a reflection. And the imaginary line that you reflect over, if you recall, is called a line of reflection. So that's that imaginary line that you reflect over. I kind of like to think of it as like a volleyball net. So in this example, we're just writing what we know about the picture. So sometimes you'll get pictures with markings and you're just going to write, what does that tell you? So I see the two one ticks. So that means those two segments are congruent. Segment DW is congruent to segment AU. And it's a good idea to practice writing these things that you see are congruent. We are actually going to get into proofs here in a couple lessons, and this is good practice to kind of set up for that. I also see the two ticks in segment KW and in segment LU. So that means those two segments are congruent. Now for the angles, I see one arc through angles D and U, so those are congruent. Angle D is congruent to angle U. And I see the two arcs through angle K and angle L, so those two angles are also congruent. Angle K is congruent to angle L. Now if you look at these triangles though, even though they have some congruent parts, we can't say the triangles themselves are congruent because I don't know anything about angles A and W. They might be congruent. And I don't know anything about KD's length and AL's length. Notice too though that, for example, the two-tick segment on the first triangle connects the two arc with angle W, which we don't know anything about, but the two-tick segment on the other triangle connects the two arc angle with the one arc angle. So right there we already have a discrepancy. So in these two triangles, there's not enough information to say whether these two triangles are congruent or not. All we know is this information over here. All right, here's our last example. We have a congruent statement. Triangle DOG is congruent to triangle CAT. So that means D goes with C, O goes with A, and G goes with T. It says DO equals 10, OG equals 12, DG equals 16, and AT equals 2x plus 6. Then what does x equal? So definitely we probably need to draw some pictures. So you can just draw two generic triangles. Now you know they're congruent. We're going to write how they're congruent. D is congruent to C. Oh, would probably help if I labeled my triangles. If you label them in the way that they're congruent, kind of orient them the same direction, it'll be easier to label. So D and C are congruent. O and A are congruent. G and T are congruent. Okay? Which also means DO and CA are congruent. OG and AT are congruent. And DG and CT are congruent. So now my picture's all labeled up. Are all marked up. Now we need to label it with the links. Remember when you see two capital letters next to each other, that indicates a length. So the length between D and O is 10. The length between O and G is 12. The length between D and G is 16. And the length between A and T is 2x plus 6. Okay, so there's definitely some unnecessary information in this picture. I'm going to start with the expression that has my x in it, 2x plus 6. That corresponds to this 12, and those are congruent. Remember, when two things are congruent, they're equal in size, which means I can put an equal sign between them. So I can say 2x plus 6 equals 12, and then I can solve. I don't need this 10 or the 16 to help me, right? I just need these two corresponding sides. So let's go ahead and solve this equation. We'll start by subtracting 6 from both sides. 2x equals 6. Then we'll divide both sides by 2. And x equals 3. So that's how you would kind of do an application type problem. All right, prepare your questions, and I'll see you in class.